Now, to help us get an idea of what exactly we should talk about, I'd like to take a quick audience poll of what your roles are in your work. So for content for developers, these are mostly the thinking of people who program or come close to that. Please raise your hands. Half, third-ish, 40%? Okay, for those who are content creators and come here to learn about different material systems. We have a few of those. Anybody on the business side, this would include sales, marketing, product management, people like that? And for those here who are looking to cause trouble. Great. So we're here, we have 55 minutes, and we want you to come away with an understanding of the differences and the varieties of material systems, what they're good for, where they may be lacking a little bit, where their focuses and strengths are. So if we start getting off topic, please come up with the questions. Make sure you have a mic when you ask the questions, and we'll take questions at the end. So for my background, I am an independent consultant. Right now I'm doing a lot of work for the Khronos Group. I'm a project manager overseeing all of their 3D development in the areas of glTF, 3D commerce, and also working with the OpenXR group, which was just here talking about some of their work. In particular, a couple things that we have done for 3D commerce recently has been the, which is shown on the right, is the Render Fidelity website. This is a website that allows you to compare many of our standard renderers. In this particular case, we have Stellar, which is a Dassault product, and it is a path trace renderer. On the right is Sample Viewer, which is a real-time renderer, and the application allows you to scroll back and forth, slide back and forth to see where the differences are. In this particular case, if you look at the Black King, I believe, you can see that there's a slight difference in the rendering between the two engines, and that's just a factor of the capabilities of those engines in that particular case. On the right-hand side is a few of our sample assets. These represent everything from simple test cases to very high-quality showcase assets. These listed here are showcase assets developed within the last couple of years. The artist who did all of these is sitting up here in the front. So if you have questions about the showcase assets in general or these ones in specific, go to the last person sitting. No, these would be the assets on the left. So we have presenters today, myself as moderator of the panel, and most importantly, we have Amra Tareen, CEO of All3D, Max Bickley is Senior Product Manager at NVIDIA, and Henrik Edstrom at Autodesk, where he's a Distinguished Architect. So you're going to get introductions from each of them now. So go ahead, Max.
Yeah, hey everybody, I'm Max. Like Leonard said, I'm a product manager for all the spatial computing workflows that we do at NVIDIA. And so my team looks after the SDKs and the APIs that we put out there for people who want to build spatial experiences on top of Omniverse, but also our XR streaming stack that we call Cloud XR, and that's more generalized for streaming many XR applications over a network. So before NVIDIA, I was at Pixar for about 15 years, and I've been at NVIDIA now for about 3 years.
Amra?
Hi, I'm Amra Tareen. I am a serial entrepreneur, and I'm the CEO of All3D. And we are focused on product visualization, making sellers' product look beautiful, whether it's in images or 3D players or augmented reality. So my background, electrical engineer, computer science, Harvard MBA, built companies, sold them, ended up at a retailer called Bed Bath & Beyond through an acquisition. And I realized the way people develop products today and sell products is very archaic. And basically, retailers want consumers to buy more product, and they build product that consumers don't want. And they end up promoting it, lowering pricing, selling it, and then the consumers throw them away with a very bad carbon footprint. And with 3D and virtual products, you can actually develop products, user test it, and then customize it based on what the users want. And that's what I'm trying to do at All3D for sellers.
Hi everyone, I'm Henrik. I'm a software architect at Autodesk. I've been with Autodesk for 18 years now. So our group, we work on a lot of shared graphics technology across the various different Autodesk products. So from AC products like AutoCAD and Revit to product design and manufacturing like Fusion and Inventor to some of our media and entertainment products like 3ds Max and Maya. So we try to share as much as possible, graphics technology-wise between these products. And our group is also very involved in many of the open standards around graphics. So USD, glTF, and of course MaterialX and OpenPBR that we're going to talk more about here today. So we've been very actively contributing to MaterialX for about 8 years now. And we started the OpenPBR initiative together with Adobe a couple of years ago. So very excited to be here to talk about materials.
So apparently I must have had some restaurant training because I'm going to ask Max just as he takes a drink to start us off and to describe the basics of material systems. What is a material system, and including your particular expertise and experience with MaterialX, OpenPBR, and glTF PBR?
Just a very small, easy question to start.
That's why it's first.
I love it. So both at NVIDIA and Pixar, my primary focus, I'm a lighting artist, is my background, and so anyone who works in animation or 3D knows that a lighting artist is the recipient of all the materials that artists before us will create and deliver to us. And so how you describe a material is essentially how it's going to respond to light, its color, its texture. And so it's very important if you want something to look realistic or stylized in a particular way. The material systems that we're talking about today sort of kind of span two problem areas. Things like MaterialX and OpenUSD, those are really transport systems. And so what I mean when I say that is previous to these, we didn't have a good way to describe how a material is sort of created at its atomic level, and then to be able to move it to a different application and change some of that atomic makeup. All these applications had different ways of creating their materials, and they didn't speak a common language. And so with MaterialX, we now have that basis of a common language, so we can start to move materials between those different applications. Things like OpenPBR are how we take that atomic makeup of a material and describe it to a renderer. And this is also a hard problem because renderers are purpose-built for different tasks. Some renderers want to be real-time, some are going to be slow and offline. And so how do you conceptualize what the shader parameters should be for every renderer that's under the sun, and more importantly for every computer system that has to run that renderer and sort of calculate those materials in that lighting. And so I think of these material systems as ways for really folks like us and all of you in this room to try to agree upon how we want to move material information between those applications, and then how we want those renderers to then display those materials that we create. And there's going to be compromises along the way. We're not going to come up with a material description system that can sort of list what everybody under the sun wants to make. And then likewise, we're not going to be able to describe a shader that can be consumed by every computing device that's out there. Some of those computing devices, like XR devices, are going to be really low power. Or you might have a giant render farm that can use something like RenderMan or Arnold to spend hours processing a super complex material. And so all these systems are really designed to speak to each other so that artists and designers have different paths they can take depending on where they want that material system to wind up, and then hopefully have an understanding of the pros and cons and sort of the data that might be lost or translated between those systems, but giving people a comfortable path to move easily between them.
Okay, thank you, Max. Henrik, how would these systems be compatible or interoperable? And Max, please feel free to contribute to this after Henrik's statement.
Yeah, so I mean, we saw this like PBR evolution now coming up almost 15 years ago. So at least there is kind of a common underlying model in how we describe materials these days. So these different models are relatively compatible, but they, like Max mentioned, they've maybe made different design choices based on, are we looking for the most flexible, expressive model or the most portable model that I can render on any device? So that's kind of like how they originally evolved. But the base parameters are relatively similar. So if you look at something like OpenPBR, it's very expressive. It has most of the parameters that you would need to express almost any material for very high-end rendering, offline rendering, VFX work, and etc. Whereas something like glTF PBR is a little bit more constrained, but there is a relatively straightforward mapping between the two. So there is ongoing work in trying to keep these models as compatible as possible. So you can go back and forth from one to the other. So depending on what your workflow looks like, you might want to start with maybe OpenPBR because you have a need to exchange the material between different DCCs and edit in different tools from different vendors and so on. But then if you have a downstream workflow where you need to publish to some sort of platform where you need maximum portability, you can map that to glTF PBR. So and one way to do that we leverage a lot from Autodesk is translation graphs in MaterialX. So MaterialX has this ability to express all these different shading models, including OpenPBR and glTF PBR, but also many other shading models. And you can actually express the relationship between those models in MaterialX as a graph. So you can put all the inputs into one graph and then it outputs automatically the other graph. So that makes the management of those translations back and forth much easier, because all these models are continuously evolving as material models are improving. So we're coming up with new extensions to glTF PBR, and also OpenPBR is getting new revisions with slight improvements. So it's important that we keep the mapping between the different models compatible as all the models evolve going forward. But I think we're in a pretty good place there. So whether you start from one or the other, you can always go the other way. And obviously, if you start with glTF PBR, you constrain to what you can express in that. You can't automatically get more fidelity by upgrading to OpenPBR. But the mapping is relatively straightforward between the different models.
I almost think of it like transcoding, right? It's like your OpenPBR is sort of your raw, high fidelity, high complexity version of something, and you have ways to now sort of transcode it down into something that's more compact and more sort of more streamlined.
Yeah, absolutely. And I think that analogy goes back to what you mentioned earlier with USD versus glTF. It's kind of the same thing. So USD has a lot more bells and whistles and expressiveness, but if you want something lightweight and very portable, you can translate or transpile that to glTF.
So let me ask you two a question. Can I ask?
Yes,
Leonard?
absolutely.
Because, so from my perspective, as you know, a 3D model of any object in e-commerce, whether it's a chair or a sofa or a football, you have the geometry and then you have the material model. And the parameters of the material models are, the base color, the roughness, the diffusion maps, the normal maps and all that, which is pretty standard across all of it. So my question to you is, because you're using shaders, so I would like to know in layman's terms what a shader is and how does the shader impact the rendering part of it. So if either of you want to talk about the shaders.
I'm going to let the shading architect guy over here answer that question.
Yeah, so all of the material models that we're talking about, so OpenPBR and then glTF PBR, they are just a conceptual model. So it doesn't give you the shader code, like how am I supposed to evaluate this material in my renderer. So from that conceptual model, you have to create a shader. So it's basically just the code that gets executed in your renderer, where this has a web viewer using WebGL or WebGPU, or a path tracer. It could be like CUDA or hardware ray tracer. It could be any type of offline renderer. So depending on what render you have, you take different paths to go from this model to the shader code. So let's say if you do express it in MaterialX, there is actually a built-in shader generator for all the common, shading languages that you might encounter. So if that's good enough for your use case, you can certainly use that. And then you don't have to write your shaders by yourself. But if you have a very specific use case and you know that your render needs to optimize in certain ways, you basically need to hand write the shader code that represents OpenPBR or glTF PBR.
Thank you.
So it depends on your use case and how deep you want to go into the renderer, but there is an easy path there to through MaterialX, which we certainly leverage in a lot of use cases.
So, Amra, now it's time for me to ask you a question. Okay. What do your customers want from materials? What do they want to be able to produce in the computer-generated models?
So my customers are sellers. So think of mid-sized businesses, SMB, even the largest retailer on the planet. And what they're still interested in is showing the product either in a web viewer, in a 3D player, so people can get an immersive experience, or they want to render it as images. And they actually do not care about what is the underlying pipeline for creating the 3D models and the imagery that is required. And so for them, initially when we started the company, we were using V-Ray materials and a offline rendering pipeline using V-Ray and other rendering engines. And so when we started, they were pretty happy with it because the PBR materials were restricted at the time. But what has been going on in the last 2 years is that people are moving to PBR materials. And even there is, in the industry, there is knowledge that large retailers want PBR materials and glTF and, constraining the number of poly counts. Augmented reality is an application in a 3D player, but the web is still 2D, and especially in the e-commerce. So they want to convert those images in environments and what they call in a white background, even though they have a 3D model, in as rendered images. And so it's about educating and it's about interoperability, which falls on us to make sure that we create the material once and it can be used in all different applications across different devices. So from our perspective, MaterialX, or we are actually using PBR glTF being part of Khronos, and what we're seeing is we're standardizing more and more on that than the traditional offline pipeline. But also in the last 12 months, people want more augmented reality and more immersive experience of using the model viewer on their websites, and we're seeing an increase of that as well. So
Amra must have read my questions, because my next question, after we've been talking about rendering in general, bring it specifically to AWE, and how do you render for XR? And I want to ask Max, what are the specific conditions and considerations you have that are necessary to render correctly in XR?
Yeah, and I think Amra's use case is interesting too, because from NVIDIA's standpoint, we see scale problems at kind of both ends of a single equation, which is I want to show people something that looks very real, so they know what it's going to look like when they buy it.
exactly.
But the scale at which I want to do that might vary. And we know that with massive scale comes massive compute. And so where do you find that trade-off of, oh man, is this really important for me to show an incredibly physically accurate render of something? I'll reserve 1 GPU per user who wants to look at that asset. Or no, I actually cannot actually find enough GPUs to scale to the number of users I want to show this to. So I need a pipeline that lets me transcode this information into a system that can be real-time on more devices, maybe without a dedicated GPU. And so what my team looks at from the Omniverse side is, you might have content creators who are making assets in DCCs and they want to aggregate that data together and then export it out as glTF, and that's absolutely a use case that we like for OpenUSD and for Omniverse. But then we also enable them to sort of keep our renderer in their pipeline all the way to the end of the stack. So if you want to bring that asset into an Omniverse application, use our real-time path tracer, and then from the cloud stream an interactive render, path trace render to that user, our SDKs can also let you do that. And so it's sort of like, how many GPUs do you want? And that can kind of guide like where your realism trade-offs and your physical accuracy trade-offs will be. And we don't really have a strong opinion about, you know, everything should be as physically accurate all the time, because again, those scaling issues come into the play pretty quickly.
And just adding to your point, so I definitely see a use case of streaming from the Omniverse platform. We have been building 3D configurators in real time using PBR and glTF for one of our customer who's actually, it's a woman-owned business. And it's really interesting that with this company, I actually get to interact with a lot more women-owned businesses, and especially when they're selling products. She has about 1,200 frames of sofas and sectionals and chairs and ottomans. And, you know, she could offer about 330 fabrics, but there's no way she can create as many images, all that. So we're about to launch our configurator, and she has images, and we even had to break her sectionals down by, first we made the sectional and then by components. Because first there's a data problem. You don't have all the data, even though she manufactures it, so you have to help her organize the data. But the fact that for the first time, her customers can visualize the platform, and of course there's trade-off. Even with PBR, glTF, realistic, and you know the fact that you're doing it in a web browser, it looks good now compared to maybe 2 years ago. But it's the fidelity and the trade-off of downloading all of this is always a problem. You know what I mean? And if Omniverse could make it real, extremely real, and stream it, that is one way of doing it, which I never sort of thought about, but now I will to do it.
Well, and what's cool is we even have customers who just want to quickly switch between the two. Maybe you have somebody who's just browsing a website and seeing a glTF representation of a product, and then they're honing in on what they want, and they go, I want to see this with physically accurate lighting and shadows and all that stuff. You know, something like glTF PBR can let you guys have a single asset, but that can render in both of those contexts, and they'll look practically the same. You'll just sort of get the benefits of that real-time path tracing on top when they want to tap into that higher quality render.
Max, explain to some of our users what path tracing is, because I think,
So path tracing, essentially, as we've gotten further into our journey of computer graphics, we've found more ways to simulate more accurate ways that light traverses and reflections traverse through the physical world. And so, of course, as we've made GPUs a lot bigger, we can sort of simulate what we call more paths. And so a path is essentially a renderer going out into a scene, sending rays from a camera and inspecting everything that ray bounces off of, all the material properties that ray hits, and then all the additional materials and lights that ray hits as it continues to bounce through the scene. And so that's sort of the foundational technology that you need to get an accurate representation of something like this room, is to evaluate every single material and light, and then also how they all interplay with each other.
Thank you. And I just wanted to say, with 1,200 frames and 330 fabrics, she can create, or her customers can create 2 million permutations of what they can view. There's no way she could actually do that without doing the real-time version. Because even if you rendered it offline, the rendering costs are still there. Yeah. With real-time, it's not there.
So Henrik, giving you a chance to contribute to this is, what do choices of material systems have for the workflow or the pipeline?
Yeah, it kind of goes back to what we just mentioned, that you have different needs to sometimes visualize something in a very shareable form, maybe on the web, or sometimes you need very high fidelity. So it's completely dependent on your use case. And you know, from our standpoint, we have so many different customers in different industries and different areas, and they have all different needs. So if you're a VFX artist in Maya and you're using Arnold or RenderMan or V-Ray or something like that, you know, that informs certain choices. You probably want the most expressive material model and focus on, you know, visual fidelity. But in other use cases where maybe you're an architect and you need to share your design with a colleague over the web, you might go with something that is more lightweight. So it depends on the use case. And I think what you mentioned earlier, for the vast majority of our customers, they don't really care about what's the underlying technology, what's the shading model, or what the material system that's running behind the scene. They only care about it just works across, the different tools that they use. So if we look at our biggest, industry is architecture, basically. So when you're designing a building, let's say in Revit, of course you have a need to see like the materials as you're designing the building. But then you might want to go into XR. You have a different third-party tools. It could be Unity or Unreal or something more specialized for AEC visualization, or tons of different plugins for Revit for those purposes. And you just want to make sure that the material works across. And you might go into other experiences like a richer experience that you build in a game engine where you can kind of walk through the building and experience it, whether in XR or on a 2D screen. But, the more you can have the same materials look the same and avoid having to re-author them for every individual experience, the more time you save and, the smoother the whole design process becomes. So we see a big need for like supporting a lot of different tools and having materials just seamlessly work across all the different tools and ideally look as consistent as possible. And I think we made a lot of progress as an industry there through the open standards that, we more and more align on the same material systems and models. So you get closer and closer to that seamless workflow. You can have one shared material library that you can use in all the different tools, whether it's an Autodesk tool or any other vendor. So, but yeah, for the most part, the technology that runs behind the scene is not important to the end user. There are some exceptions, of course, Maya user, 3ds Max user, they might care about actually what's behind the scenes, but for the vast majority of architects or engineers or designers, they just want it to work. So. We make the choices for them pretty much, and hopefully we make good choices there.
And I'll just add to it, because when we started, initially we were doing V-Ray material, and in a model viewer, it looked awful. But now there's interoperability going on that, even V-Ray has PBR support, and MaterialX will go to all other different renderers in real time. And so we're getting there, but I do believe we're not there yet still, so.
Max, if for the products you support, and Henrik too, for those, so Max, primarily OmniVision and anything else that fits into this, how do your products contribute to what Amra has to do to make her customers happy?
Yeah, so like our primary role is making sure our products support things like glTF PBR, support things like OmniPBR and MaterialX. And so Omniverse in the past year has had a number of releases that have both increased our MaterialX support. Starting in our next release, we're switching over to OpenPBR as our default PBR material that's in there. And so making sure that our tools are sort of always going to be able to sort of do this transcoding that we're talking about, I think is one of the most critical roles that we can play. Because again, we don't really have a say in where people's data comes from, and we don't want to be too opinionated about what our tools will do to that data as it kind of passes through our part of the pipeline and then winds up in its eventual location.
Yeah, and I mean, we at Autodesk, we're obviously responsible for a lot of the content creation tools, whether it's a Max or Maya for content creations in those tools, or more CAD, AEC, BIM type of tools. So I mean, our job is basically to make sure that we have these support for these material models, so you can go to any downstream workflow. But yeah, to your point, we're not completely there yet, so it's ongoing work. But we see more and more support every year, like not just in our products, but also in products across the ecosystem from all kinds of vendors, getting better support for MaterialX and OpenPBR, and glTF PBR when that makes sense. So we have support for glTF PBR in some of our products, but not all of them yet. So it's hopefully that's coming more and more as time goes on.
It's probably worth mentioning too that even when we get to this perfect world of material translation across applications, we now expose ourselves to other areas that aren't yet unified across tools like lighting and like I mentioned, renderers all kind of having a slightly different approach on maybe how they simulate a camera lens or things like that. And so, there's still unsolved problems that sort of surround the material ecosystem that are also kind of ongoing.
So AI is not going to replace this whole MaterialX thing.
Not yet. We're getting close, but no, not yet.
So before we go on to the final sets of questions, I wanted to let you know that we're running close to the time when questions are ready. So please get your questions ready. We did build this in anticipation of a lot of audience questions. If it comes short, we'll fill in with other material. So don't hesitate to ask. We're planning on that. So, Amra, you've heard several different material systems and products discussed. What in particular do you find that's missing that would really help your customers from any of the product suites, or perhaps doesn't from everything because it just doesn't exist at all?
So I will tell you, our customers say this all the time. It's not a photograph, it's a rendering. You know what I mean? And I always ask them, how can you tell it's a rendering? And I think the biggest thing is the lighting in the scene is a big problem. Because if it's an overexposed lighting, the product's going to look flat. If there's not enough contrast, the product's going to look flat. Also, the focus, it's just very interesting because, how you focus. So we have a browser-based platform which anyone can use and take photos of their products if they want it rendered offline. And lighting is the biggest issue, apart from materials, because we know we'll convert them into different and we'll fix those, and in the pipeline it gets. So as you said, I know we're getting close to solving the material problem, but we're still not there yet. Maybe another year or two we'll get that materials become really interoperable. But lighting is so key, and I think even in the PBR glTF world, lighting is not resolved if it's in the browser base today. You know what I mean? So you have to bake lighting or do ambient occlusion to make the product look with the right shadows. So there's still a lot of lighting issues that if we solved it, I think we would just scale very fast because our customers keep saying, oh, it's an issue here. And we do self-serve and managed service. But interestingly enough, one of our potential customers now want us to do AI imagery because product visualization is also moving to AI imagery. And my AI team's also trying to create 3D models with AI and using the foundational AI models. And the issues are actually very similar to what is in the artist-driven part of the platform that we've faced and solved. It's product fidelity, it's lighting, it's showing product in an environment and making sure the color and textures are actually, we may have the color and textures more accurate in a rendering, but they want it to match a certain, because they're so used to photoshopping and making the product look different than what it actually is.
Tuning it,
Exactly. And I think that is still a big problem because with path tracing, your product's not going to look the same as in a white background with other products in there, the color's not, but they still want it. And I think those things in education is still a big problem.
Yeah, I mean, you mentioned that earlier. Like after we solve materials, lighting is maybe next, and then to your point, you might need path tracing for certain types of materials, especially if you have transparency or interreflections. Just faking that through a real-time rasterizer, you run into limitations at some point. So we don't yet have real-time path tracing on every device. If you have a high-end, desktop machine, or you're running on a server and streaming to your local device, you might be able to use that today, but it's not yet like completely mainstream. So you have, real-time path tracing on your phone or your XR device, like on device. So that's probably still, some times away. Yes. But we're not there. Even if materials themselves get solved, to make them look real, you need the lighting and you need the renderer that can actually evaluate the materials.
But I would argue we want to solve materials as best we can before we tackle lighting, because there's nothing worse than materials changing after you've done your lighting. So.
I think that's one thing we can agree on. Like materials is probably, or has been the biggest pain point. We're getting kind of close to the end of the road there, but definitely, we should start with materials before tackling these other challenges that remain.
It's good to know if this NVIDIA thing doesn't work, I'll just go back to doing lighting. Sounds like there's plenty of work.
Oh, believe me, it's still a problem. Even with AI images, it's a problem. As you go from 1K to 2K, the lighting changes, and the models that are out there are trained on 1K web images, I would think. That's why it is, they're 1K optimized. So going to 2K and 4K, which our customers demand for e-commerce, even though the web is still 1K, but it is what it is.
And it's complex to train an AI model to understand exactly how light should work in a particular context. It's if you look at the corpus of like what can you train a model on to sort of have it learn lighting, there really isn't a data set out there that kind of establishes a baseline of what that should be. So it still feels like it's a little ways out.
Well, we're trying. We're always trying.
Yeah, we're always trying. Yeah, for sure. And in certain cases, like outdoor lighting is something that I think some of the models are getting pretty exceptional at.
Oh, really?
Yeah.
Okay, good to know. Maybe we should focus on
Yeah,
outdoors.
Everything's going to be outside, nothing inside.
We're going to open up to questions now, but as you're thinking of questions, I want to make sure that we achieve the goals that we started with. To get an understanding of material systems, to understand the differences between MaterialX, OpenPBR, glTF, understand the differences between path trace renderers and real-time renderers. Now, I'm not expecting full technical understanding, but at least as somebody mentions the term, it doesn't set you on edge and make you so unfamiliar with what's going on that you lose the rest of the conversation. So, please, we have questions now. And please raise your hand, and Tina will come, right, with the mic. And unfortunately, the first question's right in the middle in the back, making it difficult to get to.
Where was it? Oh, okay.
Hello. Thanks for the talk. So one of the questions I have is, with like a new emerging technologies like Gaussian splats, has there been sort of any kind of insight factoring into the development of traditional material systems, like mesh-based rendering and like hybridizing that? Or is that something that's completely different from the pipeline?
I don't know. I think it's changing pretty quickly, so I won't say like it's not going to cross paths with what we're doing, but I could see a future where describing some types of Gaussian splats could overlap with MaterialX and sort of having a library to draw that upon. But at least in our space, we view splats as kind of something you've captured and you're not going to change. And certainly you could augment those splats with additional 3D data that could have some of these material systems that we're talking about alongside that, and that's how those two things I could see interacting. But how material systems apply to Gaussian splats, I don't know, I haven't really thought too deeply about that.
So we're working on it, and that is the hardest problem right now. Because with AI, generative AI creating 3D geometry is pretty close, but the materials and the issues with it are still there. Maybe that is through MaterialX and trying to standardize.
Yeah, exactly.
It may help.
Extracting 3D information from a Gaussian splat and turning that into materials, that's absolutely a workflow that folks are jumping on.
So we've got a floor mic up there, so you can queue up there, and I'm going to bring the mic down for you for direct question.
Thank you, Leonard.
I've got a question, I think probably for Henrik, although maybe anyone. Often there's a discussion between the balance in trade-off of what's put in the material and what's put in the shader. And the more you put into the material, the bigger that your asset's going to get. And the more you put into the shader, the more compute you're going to have to do as you're rendering it and all that. Is there a world where you see learned techniques, I'll say, rather than maybe AI, learned techniques into those shaders where all I need to say in my material is this is a checkerboard pattern, just the text, and then when I'm rendering it, my shader is very smart and says, I know what a checkerboard pattern looks like. I'll do that automatically for you. Do you foresee anything like that, where we get some insane compression of the material, but...
No, and maybe Max wants to touch on more. I know there is a lot of ongoing research in that space. We're not quite there yet, but I can definitely foresee that being a big thing over the next few years. So it's going to be interesting to see how that evolves. I know NVIDIA has some neural materials which is more or less doing what you just described. You take a very high heavy description, like high fidelity description of your material, and then you can put that through a neural network and get something that's very lightweight and easy or fast to evaluate. But what we have right now that is available in production is, you have to make some of those trade-offs. And one we see a lot, and we've actually done a lot of work on glTF recently, is instead of having very high resolution, heavy textures for your PBR model, using procedural textures, which is relatively new in the glTF space. But we've added MaterialX support recently for procedural textures in glTF, and we think that will help a lot with making assets smaller and more portable, and depending on what hardware you're running on, it might actually be faster also, because of less bandwidth usage and whatnot. But yeah, right now we don't have that full AI solution, but several companies are working on that. So
yeah, neuromaterials gets close, but I don't think it's been sort of successfully pulled back into this interchange discussion. It's kind of something you sort of feed into a neuromaterial and get your neuromaterial out, and you get that kind of level of compression that you're looking for. I think it'd be cool to start to see that generalized across more systems.
That's okay. You can ask any question.
Safe. Don't worry. You're safe.
Prepare
I'll
yourself.
ask you an awkward thing.
I don't
No,
care.
actually, it's just a simple thing. Do you think compute power will, because that seems to be the biggest problem, right, is compute power. But do you think software can save us from this? Because we achieve photorealism now with rendering, right? That we've all hit that moment where the rendering, sometimes you cannot tell the difference in a photograph and a render, but obviously in real time, we still have quite a way to go. Do you think processing power, GPU, CPU power, is the way to go? Or do you think software and smart ways of building software around it can fix that?
It's a loaded question. I mean, not like in a bad way, but it's we can hypothesize of like a future where maybe an AI model is consuming the 3D data and just simply presenting you an image of what it thinks is inside that file, and we're not really talking about a renderer at that point. The problem space that we see, especially as it relates to AWE, is these head-worn devices continue to shrink their TDP, their power size, essentially. And so, how are you going to draw any 3D graphics on a 2 to 5 watt SoC? And so, at that point, that's when we kind of go back to this whole streaming and doing your rendering offline and pulling it back in. But, I think that it kind of goes back to what we were discussing about scale and sort of what will be the demands of scale for consuming all this 3D data that we're generating. And, XR kind of has a ways to go to sort of feel like it's going to pull that scale tension really hard, because I think today it's like, okay, I just want really good looking 3D on the web because that's just where everybody can get to it. As those winds shift, I think that problem is going to get interesting.
Yeah, I think some of the smarts can shortcut that. And I mean, one thing we can look at is just the real-time path tracing and how some of the AI techniques with denoising and upscaling and all of that is, I think, you see this graph, it's like 1,000 times, speed up to compared to where we were 10 years ago. So, I think there is room for some of that. It might take a while before you get onto those like 2 to 5 watt devices, but yeah, smarts can help. But, if nothing else, brute force compute will hopefully still keep evolving for a few more years. So we'll get closer and closer to that real-time experience with, maintaining the photorealism that we see in some of the offline rendering.
Any other questions? So I'd like to ask Amra a question.
Sure.
Is what would you want to see in this panel if you could add to it based on everything else that's occurred to help your customers better understand what's going on?
Interesting question. I think my customers are the creatives, usually the creative department, creative directors in large retail companies. Where in medium and small size, it's the CIO and the founder because they want a brand representation. I think they want to know how can they get the product visualization done at a low cost. So low cost is so important to them. And I think it relates to the scaling factor. Remember, these guys were doing physical photography. They were shipping all the products together, props, and taking a photo. 3D rendering came and making a 3D model came, and then, we reduced that price by 60%. But it's still pretty expensive to get a 3D model, a product visualization done, and all this stuff. Now they want AI images, and because there's no immersive experience without the glasses today, so I think their need in e-commerce is more immersive experiences and at low cost. And I strongly believe all 3D is still not hitting the low cost enough. If we were, I think the whole web, we would have so many customers. So to me, creating materials and automating a lot of it where the cost of creating a 3D object goes down is so important. Rendering costs have come down, and we continue to improve on it, and but it's creating the asset itself is the biggest problem today with even my customers. And then again, lighting. It doesn't look realistic enough. It looks like a rendering, which drives me crazy because it doesn't, but it's what the expectations of lighting is from them. And I think those two, if material lighting and how do we automate the creation of the object itself would help.
Okay. Any last call for questions? Jumping to the end here, Khronos does have a couple more talks. There's one more talk tomorrow, and we do have a booth, 510. It's on the show floor. Please come and visit. We can talk to you a lot more in detail. If you have questions for any of us after we end the panel, you're free to come up here or outside wherever the panelist wishes to go.
Thanks,
Thank
Leonard.
you.
Thank you for attending. The recording will be up under AWE schedules, but Khronos will also post the slides and the other materials and the links to the resources we discussed.